Evaluate integral 0 to 2 pi d theta by 1 minus 2x cos theta plus x square such that 0 less than x less than 1 using contour integration. So using contour integration we have to evaluate this where x is given by between 0 to 1. You see this is contour integral of type 1 because the integration having the limits 0 to 2 pi and also the integral function having the variable cos theta involving trigonometric function, so that it is contour integral of type 1. Okay, so the given integral is integral 0 to 2 pi d theta divided by 1 minus 2x cos theta plus x square with the condition 0 less than x less than 1. This is contour integral of type 1. So in this type, consider an unit circle C. Consider an unit circle C. Mod z equal to 1. The meaning of unit circle is radius 1 and center 0, 0, 0, such that z equal to e power I theta. Unit circle means it is e power I theta because every complex number corresponding polar form is r into e power I theta because r into cos theta plus I sin theta. Here radius is 1, so 1 into e power I theta, so that if it is unit circle, then z can be written as e power I theta. Okay, so from this you can write d theta is equal to dz by iz, and cos theta is equal to z square plus 1 by 2z, and sin theta is equal to z square minus 1 by 2iz. So if you want proof for this, refer the video definition and working rule for contour integral. The link is available in the description box. Okay, now I am going to substitute everything in the given integral. Okay, so after substituting this, the integral becomes converted into in terms of z. Okay, so that the integral over C is unit circle. Take d theta outside, 1 by 1 minus 2x cos theta. What is cos theta? This is z square plus 1 by 2z plus x square into d theta. What is d theta? dz by iz. Okay, so now here 2 and 2 cancel. Now in the denominator I am going to take LCM z. So 1 by, take LCM z. So z minus, at the same time multiply x inside, x z square minus x plus zx square, because taking LCM as z, whole divided by z, into dz by iz. Z and z cancel, and now take 1 by I outside, so 1 by I integral. At the same time, in the denominator I want to convert into a quadratic equation in terms of z, so that I want to collect z square term first, next z term and a constant term, but here z square term having negative, so that I am going to take minus outside. Take minus outside, so 1 by, so this becomes x z square, and now this is z, this is also z term. So after taking minus outside, this is minus 1 plus x square into z, and here taking minus outside, so plus x, and into dz. Okay, so now you see the denominator, all our denominator is quadratic equation in terms of z. This is z square term, z term and constant term. Okay, now you see here I can apply Cauchy residues theorem. So what is Cauchy residues theorem? Integral over C f of z dz equal to 2 pi I into sum of the residues of f of z. Sum of the residues of f of z. So this is Cauchy residues theorem. So now I am going to compare this minus 1 by I into integral over c f of z dz. By comparing this, f of z dz equal to 2 pi I into sum of the residues of f of z. Take this is equation number 1. Okay, where f of z is equal to, this is f of z. What is that? 1 by x z square minus 1 plus x square z plus x. So this is f of z. From this f of z I want to calculate residues, and substituting in the first equation you will be getting the answer. Okay, so I want to find out the residues by putting, first I want to find out the poles by putting denominator equal to 0. So put the denominator equal to 0, x z square minus 1 plus x square into z plus x equal to 0. So by equating denominator equal to 0, after solving this we will be getting poles. Okay, first I am going to find out the poles. So this is quadratic equation. I want to solve this equation. So x z square multiply minus inside and z inside, minus z minus x square z plus x is equal to 0. To solve this, take a z term outside in the first two. So z outside is xz minus 1, and in another next two term take minus x outside, xz minus 1 equal to 0. So xz minus 1, xz minus 1, take xz minus 1 outside, inside z minus x equal to 0, and xz minus 1 equal to 0 or z minus x equal to 0. So from this z equal to 1 by x and z equal to x. Okay, so there are two poles. One is 1 by x, another one is x. Okay, so now I want to verify which one lies inside, which one lies outside. Okay, but you see in the given problem they are given condition 0 less than x less than 1. So x is less than 1, therefore x must be lies inside C, because C is a unit circle with radius 1. So if x is less than 1, definitely it should be lies inside C. Okay, so here z equal to x lies inside C. Then what about 1 by x? You see, x is less than 1, between 0 to 1 means 1 by x must be greater than 1. For example, I give you, suppose if x is equal to 1 by 2, 1 by 2 is less than 1, between 0 to 1. What about 1 by x? 1 by x is 2, 2 is greater than 1, so it is lies outside C. Therefore, here z equal to x lies inside C, inside circle C, but z equal to 1 by x lies outside C, the circle C. Okay, so only one pole lies inside the circle C, so that I am going to find out residue for that pole. Okay, what is the formula for residue? Residue of f of z at z equal to a equal to limit z tends to a z minus a into f of z. So this is the formula for residue for the simple pole z equal to a. Here z equal to x is lies inside C. So that I am going to write, or I am going to find the residue for z equal to x. So residue of f of x at z equal to x is limit z tends to x z minus x into f of z. What is f of z? This is f of z. Okay, so 1 by x z square minus 1 plus x square z plus x. This is f of z. Okay, so limit z tends to x z minus x 1 by this quadratic equation having two roots 1 by x and x, so that it can be written as z minus 1 by x into z minus x. But the coefficient of z square is x, so you must write this x outside. But already we discussed in the previous problem, the coefficient of z square you must write, then the roots can be written as z minus 1 by x and z minus x. So this is the procedure. Okay, so here z minus x can be cancelled. Now you can put z equal to x here. So 1 by x into x minus 1 by x. Okay, simplify. 1 by x into cross multiply x square minus 1. X square minus 1 by x square minus 1 by x. X cancel. Finally, the residue is x square minus 1. So this is the residue for z equal to x. Okay, you can substitute in the first equation. What is the first equation? So this is the first equation. Sum of the residues as we have only one residues because only one pole lies inside C. Substitute here, you will be getting answer. Okay, so this is the first equation. I am going to substitute in the first equation. Okay, now listen. Our residue is 1 by x square minus 1. So I am going to substitute here. So now I cancel. So minus 2 pi into sum of the residues as only one residue, 1 by x square minus 1. Okay, you can take minus inside. So finally the answer is 2 pi by 1 minus x square. So this is the solution of the given problem.